So in problem 43 of chapter 26, we were asked how long does it take for an energy stored in the capacitor to reach half of its total potential energy in terms of the time constant RC. And we have this circuit here, and we can use what the derived formulas we have. So we can say Q charge equals the final charge over 1 minus E negative T over our time constant RC. Now we want to find energy, and so we know that energy equals 1/2 CV squared, and since V is just Q over C, this evaluates to 1/2 Q squared over C. Now what we do is we substitute this for Q, and we end up with 1/2 Q final squared over C times 1 minus E minus T over RC squared. And since this is just energy, except this time it's the final charge, we can say that this is the maximum energy. So U max times 1 minus E minus T over RC squared. Now the problem is asking us how long does it take for the capacitor to have half of its possible charge. And so since this is a total charge, this has to equal half. So if we set this equal to half, we get 1/2 is equal to 1 minus E and then that just evaluates to 1 over root 2 equals 1 minus E minus T over RC, and then we can say that, well, if we just skip some steps, we get ln of 1 minus 1 over root 2 equals negative T over RC. And once you evaluate this, you get negative 1.23 equals minus T over RC, and so T equals 1.23 RC, or 1.23 of our time constant. And that's our final answer.